Hey everyone, alright, so we are going to keep going here. So we are looking at linear functions. So when we look at the word linear, we notice that it has the word line in it, okay? So we are going to be looking for things that have a straight line. So a linear function is actually a function that forms a straight line. And this is going to be very important to grasp, because once you've got this, then we're going to be going into slope, and so that's why this is going to be important. So the way that you can tell whether or not a function, whether or not a function is linear depends on the function, how it's represented. Represented here. It says, do the points on the graph form a straight line? Okay, if they do, then it is linear. So here's the difference between linear, straight line, nonlinear, not straight line. Okay? Alright, so when we start to look at linear functions, alright, we're going to look here. So once again, our tables are lists of ordered pairs. We want to calculate the change in the y divided by the change in the x from one ordered pair to the next. Okay, this should be the same. Alright, so when we talk about the change, we're talking about what is happening from one point to the other. If it is changing the same, then it's going to be linear. If it's not, then it's different. So when we look at the change, so we remember we write them in order from least to greatest. Okay, and that's just writing them here. We don't do that over here on the y's, but then we're going to look here. So what is happening from -5 to -3? Well, that is a +2. Okay, there's +2 here that's happening to make this go away. Same thing is happening from -3 to -1. This is a +2. And then finally from -1 to 1, that is a +2. It is changing right there. Alright, and then this is a +4, but we know if we added 2 here, that on this line we could still find a 3 right here. Alright, whenever we look at what's happening from here, we want to see the same thing happening, that we're going to get the same. So 8 to 5 is -3. 5 to 2 is -3, and 2 to -1 is -3, and then a -6. But once again, if I -3 in here, I would actually end up with a point of 3 and -4 on that same line. So that is something that would actually, and if we reduce this, we would still end up with the same thing going on here. So the change of the y, so remember we're talking about change of y, so this would be -3 to +2. Okay, which would be -3 halves if we were looking at it. Same thing here, -3 over 2, -3 over 2, and -6 over 4. Well, -6 over 4 actually reduces to -3 over 2. So this is our change, and that's what we're going to be talking about, or our slope. Eventually we will be getting into that. And so this would be the same. Let's look. So when we talk about it, so change in y over our change in x. Okay, from each row. Now let's see what's happening here. So this one, I've ordered it 0, 1, 2, 3, 4. Okay, and let's see what's happening. 0 to 1 is +1. 1 to 2 is +1. 2 to 3 +1. 3 to 4 +1. Okay, that's fine. Now let's see what's happening with our y values here. 1 to 2 is a +1. 2 to 4 is a +2. 4 to 8 is a +4, and 8 to 16 is a +8. Okay, so if we wrote the changes over here, we would have 1 over 1, 2 over 1, 4 over 1, and 8 over 1. Alright, so because these are not the same as far as our change is concerned, then this is not a function. Not linear, excuse me, not linear. Or non-linear, same thing here. Alright, so let's look over at some examples on the back and answer some other things that are going on. So with equations to me make it a little bit more simpler. Equations should have no exponents. So if they have exponents, we know like that should be a red flag right there. That would be like the one from yesterday that had the little curve to it. So because it had the exponent on it, then we should know that that's not going to happen. No variables multiplied together. No variable under a square root slash or radical. That's the other name for it. Square root symbol or radical symbol. So for instance, the square root of x. Okay. So no variables multiplied together. So when it says it, we should have nothing like this, x, y. Okay, and we should never have x squared. Those are your examples. And it must have an x, a y, or both in the equation. If all of these statements are true, then you know it's linear. Okay? So, let's look at the first one here. X equals y. So it does have an x, it does have a y, and it has both. It is not an exponent. They are not being multiplied together, and they are not under a radical. So therefore, it is a linear equation. Okay? So it must have an x, it must have a y, or both. And it's got that. They are not being square rooted or using the radical symbol. They are not being multiplied together. Okay, that's the difference there. So here it's not being multiplied together. This one it is being multiplied together. Okay. So this is linear. X equals 7. It can have an x, a y, or both. It has an x. Okay. Alright, we've got a y, we've got an x, we've got a y, we've got an x and a y. There's no exponents, they're not being multiplied together, and they're not square roots. So here's an example of all the non-linears. Multiplied together, check. Exponent, check. Radical symbol, check. So that's how we know it's non-linear. Non-linear right here. This one, they're being multiplied together, so non-linear. And exponent. So those are all examples of nonlinear. So definitely look at these in your notes whenever you're doing it so that you can see that this makes it nonlinear, this makes it nonlinear, that makes it nonlinear, that, and that right there. Okay, those are all reasons. There's another reason why it wouldn't be nonlinear. Okay? Alright, and then let's look at these practice real quick. Okay, we're going to tell if it's linear or non-linear. Okay, well, what did we say that a linear line is a straight line? Is this a straight line? Nope, so that's non-linear. Is that a straight line? Nope, that's not a straight line, so that's non-linear. This is a straight line, so this is linear. And this is curvy, which is definitely non-linear. Okay, so remember we looked at our change of our x over, or our change of our y over our change of our x. So let's see what's happening here. So -4 to -3 is a +1. -3 to -1 is a +2. -1 to 1 is a +2. And 1 to 1 is a +1. Okay, so this one is going from 5 to 4, which is a -1. From here to here is a -2. From here to here, -2. From here to here is a -1. So we're going to put those over each other and see if they reduce to the same thing. So remember, it's our y first. So negative 1 over 1. Negative 2 over 2, which is going to reduce to negative 1 over 1. So that's still the same. Negative 2 over 2, which is still the same. And negative 1 over 1, which is still the same. So because they all ended up being the same in our changes, we know that this is linear. Okay, not much space here. Negative 3, negative 3, negative 2, negative 2. That would be minus 1, minus 1, minus 1, minus 1. Okay, so if I put these over, okay, if I put these over, I've got to put this one first. So negative 1 over negative 3. Negative 1 over negative 3. Negative 1 over negative 2. And negative 1 over negative 2. Well, these all will go to plus. So that would be plus 1/3, plus 1/3, plus 1/2, plus 1/2. Okay? So because of this and these not being the same, this is non-linear. Okay, whenever I look at it in an ordered pair setting, not too many times are you going to have this, but same thing. So I'm going to see what's happening from here, and here, and here, and here. And then I'm going to see what's happening from here to here, to here, to here. Okay, so from negative 8 to negative 5 is a plus 3. Negative 5 to negative 2 is 8 plus 3. Here to here is a plus 3. And here to here is a plus 3. Okay, remember that's my x's. And then I'm going to look at my y's. So here to here is a plus 2. Negative 3 to negative 1 is a plus 2. Negative 1 to 1 is a plus 2, and negative 1, or positive 1 to 3 is a plus 2. Okay, so each one of those is going to be 2 over 3, which makes it linear. Okay, because this is the thing about math, is that when it's supposed to work, it's going to repeat in patterns, just like we did whenever we were younger. Okay. Negative 10 to negative 8 is a plus 2. Negative 8 to negative 7 is a plus 1. Negative 7 to negative 4 is a plus 3. And negative 4 to 1 is a plus 5. (10 to 8 is a minus 2. 8 to 7 is a minus 1. 7 to 4 is a minus 3, and 4 to negative 1 is a minus 5. Okay, so we can see whenever we're looking here that we have all different numbers. It's scattered out, so therefore it is not linear. Actually, that is wrong. Hold on here, because I've got to put these over each other, and then I'll see the pattern here. So negative 2 over 2 is going to reduce to negative 1 over 1. Negative 1 over 1 is negative 1 over 1. Okay. Negative 3 over 3 is negative 1 over 1. And negative 5 over 5 is negative 1 over 1. So that does make it linear. So sorry about that. I jumped to conclusions. Alright, so let's see here. So our rules from earlier. The easiest thing for me to do is look and see what makes them nonlinear. This is nonlinear because it's being multiplied together. This is nonlinear because it has an exponent. And this is nonlinear because it has a radical. So nonlinear. And I'm just going to circle it just so I can identify it. and non-linear. Okay, now let's look. It's got an x and a y, and they're not being multiplied together, so therefore that's linear. This one has an x and a y, so it is linear. Alright? So, just like usual, if you have any questions, holler at me.